Hi, this is Dilruba, and I will be briefly presenting my thesis, real-time monitoring of train wheels and track conditions based on acoustic measurements and multivariate data analysis. The external partner for this thesis was CEMIT, and the thesis was done as part of the Master Thesis semester under the program of IAA at USM. So moving on, I'll just give a brief background to the reason or the need for study in such areas. We know that there is an uprise in demand for transportation that are sustainable, greener, and has less emissions. And rail transportation has been a transportation of choice in that regard, which has led to a growing number of traffic and an increased demand for rail transport, and which means there is more stress under the current, more stress on the current infrastructure of rail vehicles. So there has also been a growing research into areas concerning rail structure, soil substructures, and in studies concerning vibration that can cause passenger discomfort, which is one of the reasons why frequencies might be a good area to look into when approaching this kind of studies. So acoustic chemometrics is a suggested way, and I would say a rather good one, because it's mostly data driven and it takes into account multivariables, natural external forces, and noise, which are things that are inevitably relevant when considering vibrational data from train or train bodies. So here are some of the objectives that I've tried to target in my studies. I've tried to understand the common frequencies arising from this vibrational data. I've tried to see if there are patterns that have emerged that can be candidates for further analysis, that can reveal more about the rail and wheel dynamics. And I've performed an exploratory analysis, which is a very rudimentary analysis, multivariate analysis called PCA. And I've tried to give an overview, or try to establish that PCA can bring out some of the information from the data sets that I have available. It is nice to note that the experiments for the study was done on this vehicle you see here. It's a shift tractor by Grenland Rail, and the track on which the experiments was done is called Brevikbanen. So the freight vehicle basically transported limestone to and back from the quarry to Nushem's cement factory. It is also nice to note that the data I worked with was pre-existing data. It's not newer data. So any analysis done should be considered analysis that are applicable during that period. And if anyone wants to extrapolate the study, they should keep in mind that these are the subjects that the study is bounded to. Moving on to acoustic chemometrics, a bit about the flow of the entire picture of acoustic chemometrics. It is actually a very well-known diagram used across many papers that have studied acoustic chemometrics or used acoustic chemometrics in many areas. However, since I already have the data, the only parts that I have worked with in my study are signal analysis and multivariate analysis. And for signal analysis, I've used fast Fourier transform to transform data from time domain to frequency domain, and of course, principal component analysis, which is one of the algorithms under multivariate analysis. Moving on to the methodology, I've tried to gather the time domain signals. I've tried to transform the time domain signals to frequency data, and I've tried to stack the frequency data into spectrograms. So you can see that there's a lot you can do with the data, and you can process it in ways that can reveal information that you can dig into, or that can specialize areas for more harvesting of data. There is also something called S-direction that was used in the analysis, and it is not something that is found online yet. It is actually a very common reference used across Norway, at least, where Oslo is considered as reference 0, and any distance away from it is considered the certain number of kilometers from Oslo, and that is called the S-direction. Velocity is also taken into account when performing analysis, and we will look a bit into it here in the results, where I've tried to plot the velocity alongside the time domain signals. And just an interesting observation could be made just from this time domain signal data on the top right. If it's from a separate run, of course, and as you can see, there's a spike missing at the start of the accelerometer data, and the velocity is also very different from how it usually is in the rest of the data sets. So each accelerometer data here is from a single run. So you can see they're more or less constant. There are changes, but you can relate some of the changes to the velocities. Here is a spectrogram that I've got from just the vertical acceleration from one data set. And I've tried to observe the velocity changes along the spectrograms and see if I can make some relationships to it, which is a bit difficult to make, and which is why I've tried to trace back the locations where these interesting streaks have occurred in the spectrogram. And on the top right here, you can see the section of the track where the streaks occur. And you can also see that the streaks start where the velocity has the highest change or the highest gain. So this would be one of those areas where we could dig into deeper, where we could probably inspect the rail, where we could probably inspect what has been going on with the train and see if we can explain some of these patterns here. Then I've of course done a very rudimentary, a very primary PCA using an average data set, which took into account many data sets, which in turn protruded some of those dominant frequencies existing in most of the datasets. And this is interesting in a way that if you look at the explained variance in the bottom right, that tells you which principal components are responsible for most of the variation in the data. These principal components, or loadings, as you can see just on top of the explained variance plot right here, this is the loadings. The loadings are basically a combination of frequencies that account for the variation in the spectral data. So there is a lot to dig into here, but just to say in really short, the PCA has been able to provide some information as to where to look into, what kind of frequencies are responsible for the variation. And of course, this is subject to more analysis and more study and could reveal a lot more if there are more newer experience to it with more data to back up the findings. So in conclusion, the entire study was productive in a way that the methodologies and the analysis used proved to show something about the dynamics going on. But to be able to pinpoint the dynamics or to be able to be exact about it, there has to be newer experiment, more informed experiments, and so it is highly suggested that new experiments be performed. Thank you for sticking with me. I hope this was short and not too much to take in. I appreciate your patience. Thank you.